Welcome all. So last part which we were discussing was on plate tectonics, and we discussed about that how uh, all these lithospheric plates were together once upon a time in geological past, and how they moved away from each other, and what we are having them in the current position. So this was the conjectural, I would say, at that point of time before the theory of continental drift came in, that few continents were south of equator, located south of equator, and few of them were north of equator. So eventually, if you look at this configuration, the North American plate and the Eurasian plate, they definitely drifted apart from one another, but they more or less remained in the northern hemisphere only. The southern part, if you look at, then we have the India, which was located over here. It traveled a larger distance as compared to other plates, comparatively, I would say. And right now, what we see, it is sitting to the north of the equator. So the plates which were in the north of equator were been termed as Laurasia, and the bunch of plates which were together south of equator, that landmass was been termed as Gondwana. So you should keep this in mind about the Gondwana land and the Eurasia. Now, as we discussed about that initially, the person who was behind this, who identified the similarity in the outer boundaries of two continents, Africa and South America, and then he suggested the theory of continental drift. But as usual, not many people agreed to his theory, and to some extent, it was been sort of discarded, okay, or maybe not accepted. That was not enough just to have the matching of the two boundaries of the continents to say that these continents were together once upon a time. So the geologists, they worked upon the to identify more evidence, more signatures, that if suppose, for example, these continents were together, then they might have experienced similar type of climate. Plus, the rock types in this area would have been very much similar. Third was that if the climate was uh, the prevailing climate at that point of time was similar, then probably the floras and faunas, what we may come across as the fossils, might be the same. So that means that those flora and fauna existed at that point of time. So detailed studies were being carried out, and what was been identified that there was some very typical evidence which indicated that floras and faunas were seen across these continents. So that was an additional point which was like a point to prove that these continents were together once upon a time. Okay. Other than that, since this continents were in the south pole side, and south pole, if we look at now, is all what we call Antarctic or Antarctica. So this areas must have experienced glaciation, or the glaciers must have been present in this continents. Okay, so those evidence also were been identified, and typical striations in rocks which are created. These are the typical striations in rocks which are created by the movement of your glacial ice. Okay, so that striations were been seen across this continents. So this was another additional point which helped in understanding that, or having the understanding of that these continents were together once upon a time. Now, if you go back into the history, like a geological time scale, then the supercontinent Pangaea began to break around 225 to 200 million years ago, okay, and then fragmented into your numerous plates. So one thing which we discuss, just keep in mind that the landmass which was the continents which were on the southern portion of or the southern side of equator were termed as Gondwana, and the northern side was termed as Eurasia. Then the whole landmass was been named as Pangaea. And here what they say that at around 2 million years ago, there was this area was been termed as Tethys Sea. Now, if you look further, so the activity somewhere started over here around 2 million years ago, and then slowly, if you see this is the part of the India which moved towards. It started its journey right from here. The continents were like we can say they drifted apart here, and then the movement started, and the India moved further uh, to its present location. Okay, so this is the present day. So if we look at a small shot of the next, maybe I have a movie, not movie, but it's just a cartoon movie which shows that how continent might have moved apart from one another and what all features got created on on this planet. Okay, so as we were discussing that was not enough, that only the boundaries were been matched, okay, of different continents, but also the floras and faunas. Okay, so there is a typical connectivity in terms of the lithospheric plate, as we have discussed already about this, that right now what we see is that there is a very typical uh, plate boundaries over here, and these are nothing but the spreading centers. Okay, and we'll come to that. What are the spreading centers? What are your subduction zone plate boundaries, and what are your collision zone plate boundaries? Now, there are dozens of tectonic plates, or we can say lithospheric plate, and they are moving uh, with different velocity with respect to one another. Now, what drives this plate? Before we get into that cartoon movie, let us just have a brief idea about that. I explained in the previous lecture about the layer which is partially molten, and that is a asthenosphere. Now, this asthenosphere is is been heated up from the radioactive minerals decay and the decay of the radioactive minerals, and also the heat which has been coming from uh, the core part. Okay. Now, if we compare that how this convection currents, because this layer is known as asthenosphere, that what we already discussed about, is a part of the mantle, and this asthenosphere is capable of generating convection currents. Okay. So if you you can do a simple exercise or maybe an experiment. If you take a soap solution in a beaker and then you put it on a burner. Okay. So after some time, what you will find is that there is an bubbles which are coming up because the water is getting heated up. So the bubbles are coming up. That means the heated hot particles are coming up, and then they are sinking down again. Okay. So this convection currents are responsible for the movement of oceanic floor as well as the continental plates. Okay, or you can say continental plates and oceanic plates. Okay, so this is one of the understanding which was like started building up, that how this rocks or the plates which are comprised of different rocks are moving. Okay, so they are moving on the on your floating, or we can say on the, due to the convection currents which are produced in the asthenosphere. So the convection currents are also responsible, as we were talking about comparing the soap solution and all that. They are also responsible for the diverging the plate beneath another plate. Okay, so that is what we call the process of subduction. So we'll come to that part also. But in short, there are two in this figure. What we are able to see that this place is the spreading center. and this portion we termed as in subduction. So one plate is subducting below the another one, where the lighter color one has been shown as this is your continental plate and this is your oceanic plate. Now coming to the next part, as we were talking about that, uh, if we take in terms of the quaternary, not quaternary, but the quaternary period was the youngest one. But if we consider the overall, because uh, at the end of, or maybe we can say that after this, we will just focus on mostly on the quaternary part. But if you consider the overall geological time scale, then it goes back up to the like right from the origin. But when the drifting started, that we have discussed around 225 to 200 million years back. Okay, so now if you look at this one, this is the time which goes, okay, and slowly how things are developing over here. So we had the plates in the south of equator and north of equator, and they drifted apart, and like in between the plates which drifted apart, we started getting the spreading centers. Okay, so you can look at that this is the present day situation what we are having, and still the plates are moving, and still what we see is the development of the topography along various plate boundaries. Okay, and Himalaya is one of the example of this result of the plate motion and the plate collision, we can say, or subduction. Now, the plate boundaries, as we have been talking about, that they are very sharp, can be seen from space. You can identify that, okay, easily. Now, this boundaries are not same, okay, like in terms of in terms of the process, because some in some locations, what I would explain is that the plates are moving apart from one another, and that is creating that, yeah, the emergence of the magma coming on the surface in ocean, and so we are saying this as in spreading centers. Okay, now another part is, since these plates are moving away from one another, at some location they are getting subducted below another one. Now this subduction part, because if the two plates are coming closer to one another, one will sink and the heavier will sink, in the sense of like what we were talking about, the uh, the density. So the density wise, the oceanic plates, because of its composition, are heavier than the continental plates. Continental plates are lighter as compared to the oceanic plates. Also, now if you compare between the two oceanic plates, the older oceanic plate will be much denser, okay, because it got much longer span of time to cool down, hence it will become more denser, and that denser plate will be definitely heavier than the younger oceanic plate. So if two continental plates are coming close to one another, the heavier one, the older one, will sink down, and that is what we call subduction. So this subduction will be between oceanic continental, because continental will not subduct. Continent is lighter, so it will remain on the top. Okay, so it will override that plate. But if you are having two continents which are oceanic plate, then the older one will subduct. Now, when subduction take place, you have like what we have learned till date is that it has capability or potential to trigger mega earthquakes. Okay, and also goes for the collision zone. So right now what we are having for India, we will definitely discuss that part in little more detail when we are touching up about the Himalaya. But here you can, the take home lesson is that we have right now collision going on between the Indian plate and the Eurasian plate, because both are continental plates. But before these two continental plates collided, before that, we had a portion of oceanic plate ahead of the Indian subcontinent, and that oceanic plate subducted below the Eurasian plate. So we see volcanic rocks, okay, or the igneous rocks, that what we call like granite in in some portion of Himalaya. Okay, in higher Himalayas, if you go, and for the Tibetan side, which is also we call the suture zone area, there we see granites, and that is your a result of the intrusion of the igneous rocks. Okay. So this picture shows that there are different type of boundaries which are been seen between different plates, and they are not same. Okay, so some are like you are having the divergent plates, and some are having the transform plates. One thing I forgot to tell you, that one is the subduction, okay, another is divergence you are having, and third is the plate may subduct, for example, obliquely, or they will just pass each other. Okay, so that is what we call transform margins. Okay, so let's see in more detail. And again, another point, that this plate tectonic movements or the plate tectonics were responsible for giving us that part we have already noted down somewhere, the deepest part on the earth, and we can say the tallest or the highest point on this earth, that is your Mount Everest and Mariana Trench. Okay. Now plate motions, if we what we were talking about, that these plates are moving with different motion, they have different velocity in different direction they are moving. So velocity based on the GPS measurements, okay, are been shown here, and this scale here of the plate motion is given as a 10 centimeter, and this is 5 centimeter. So if you compare the Indian part, then it is more or less little higher than your 5 centimeter. That means the Indian plate is moving towards the Eurasian plate. This is Eurasian plate, and this is your or Tibetan plate, you can say, and this is Indian plate. So Indian plate is moving around, like you can say, around 55 millimeter per year. Okay, so this is the sense of movement, like is we can say the direction of the movement is it is northeast direction it is moving. Okay, so this is your Eurasian plate, and if you look try to measure this will be around 55 millimeter per year, or you can say 5 centimeter per year. But in some locations on this planet, you can see the motion is almost close to or more than 10 centimeter, which is much higher. And this area, which is having, this is the Nazca plate, we will come to that also, but this is a Nazca plate, and this is your South American plate. Okay, and this was the area which was responsible in triggering your one of the largest earthquake till that date we have recorded on this planet is 1960 Chilean earthquake with magnitude 9.5. So these are amongst the one of the most dangerous regions. Okay, other than this, if you look at the plate motion in this region, that is the in the Pacific region, then also here you can see that most of the plate motion is much higher as compared to what we are having in other regions. Okay, and again we'll come to that point, that what are these arrows are indicating. These arrows are indicating the plate motion, and the portion of this plates, okay, like Tibetan side, it is not in the same or similar direction, or they are not, they are pinching out, or they we can say they are getting squeezed out in the east side. Okay, so these are the points which also helps us understanding that what will be the scenario in future after thousands of years or millions of years. Okay, these plates will result into the formation of different landforms, or completely they will change their direction. We don't know, still need to understand those things. Okay, but if you compare them with the this plate boundaries, if you compare with the occurrence of the earthquake, or you try to see the alignment of the earthquakes, then in this region, as I told, that If you are having subduction, then your plate is going deeper, okay, and this depth will also triggers earthquake. So earthquake will be seen occurring at different depth, okay. So we say deep earthquakes, intermediate earthquakes, and you are having shallow earthquakes, okay. So this three type of earthquakes which are been shown with the different dots on your figure. You have red with the deep focus earthquakes. What do you mean by focus? That also we will talk about later on. But in short, if I explain, then if I put it in 3D, then this plate is moving down, okay, and there is an this plate is riding up over here. So this is a plate which is riding up here, and then you have this portion is subducting down here. So what we see is that if the earthquakes will occur on this plate because of your subduction going on, okay. So we have deep earthquakes, we have shallow earthquakes, and intermediate earthquakes, okay. So if you have we have red dots, then light slight violet, and you are having gray one or blackish. So mostly this type of earthquakes are been seen in the subduction zone areas, okay. So you have this where you have Nazca plate and South American plate. Then you have also shallow, mostly shallow earthquakes in this region. Of course, there is a subduction going on here, but this region is, if you look at the arrows here, okay. So this portion of the plate is moving like this, okay. And this plate, if you see, then that means that this the motion over here is like this, okay, more or less. The plate is moving in this direction, and there is an vector here. So that what we call sort of an like this is at an angle here, okay. So this goes like this goes like that. So you have an oblique convergence over here. So mostly what we see shallow earthquakes. Now you come down to this area, then what you see is mostly all type of earthquakes you're going to see, okay. You have shallow, intermediate, and deep earthquakes, okay, in this whole region. Another important point, if you try to note down, that as you move towards the Andaman side, again the plate motion is over like this, okay, the Indian plate, and this portion is also moving like that, okay. So there is an other than the subduction, like along with the subduction, what we have is the oblique subduction, we can say, or oblique convergence. In Himalaya, what we see is mostly shallow earthquakes. Again, over here we have shallow earthquakes, and along the spreading centers, okay, mostly what we see is the shallow earthquakes. Now, next lecture we'll see more in detail about this distribution of earthquakes, and we discuss about the plate boundaries, okay, what are the different type of plate boundaries. So with this we'll stop here and we'll continue in the next lecture. Thank you so much. Namaskar.